లేదు ఇక్కడ ఉంది కదా అక్కడ వేరే ఉంది.
Done.
Press and hold both volume keys for 3 seconds to use talkback.
Don't turn on, huh?
Talkback and don't turn.
Turn out, సార్ చూపించేటప్పుడు ఈ మొబైల్ ఏది తీసుకోవాలి ఈ స్టిక్ అట్లా ఫిక్స్ ఉంటుంది.
ఎలా ఉంది సెషన్? తక్కువ కదా టైం, చాలా తక్కువ సేపు చేశాడు. యా, నాట్ ఎ ప్రాబ్లమ్. ఐ థింక్ యూ గాట్ రిఫ్రెష్డ్ అగైన్ బై ద కల్చరల్. నో, not a worry. After the session we will be having another cultural event. Yeah. Come on. Attention everyone. Excuse me. Yeah. అయిపోయింది రిఫ్రెష్మెంట్, అయిపోయింది ఎక్స్ఆర్ గురించి సెషన్ అయిపోయింది సీనియర్స్ తో. నెక్స్ట్ లెట్ us go with another session by Sri Sadand sir garu, who has come along from Hyderabad and came here to give a session on robotics. And I would like to call upon Sadand sir on the stage. Sir, please.
Yeah, can you? Yeah. Yeah. Better. Yeah, if you all can hear me, I'll start off. Can you? Yes. So I'll start off with the brief. Yeah, sure.
Welcome, sir.
Yeah, thank you. Oh, thanks. I'll keep it. I'll definitely take it with me. Yeah. Thank you all. So, I thank the organizers and especially Mr. Harnath Garu, who was my contact person in GPRVC. But I would like to congratulate Chekudar for his fantastic presentation. It is very difficult as a speaker who is following him to match his, presentation. You told, if we summarize your presentation in one word, I have one word for it. It is dazzling. Yeah, I hope nobody used that word. It's a dazzling presentation, and yeah, please, thank you. So very rarely we see such presentations. Today what I have to show you may not be that interesting, but these are emerging technologies, and this is where the research is progressing, and the job opportunities are there. So congratulations once again, and thanks all organizers. And what's the time now? 12. Maybe I'll take 12:45 up to another 45 minutes. I don't want to be between you and your lunch. So let's start off. So are you sure that all of you can hear me? Yes. Very good. Good. So yeah. So I think at some point during your discussions or web search or YouTube videos, you might have come across things called automated guided vehicles. Yeah. So any idea what this is? Yeah. So Tesla is, yes, it's a very big automated guided vehicle, but we are not going to. I'm not going to talk about Tesla. Yeah. So we are going to talk about something which is used in intralogistics. That means these are guided vehicles which are used in warehouses, in hospitals, in hotels, in many places. Yeah, we will see that. So I have divided my presentation into maybe two broad what you call parts. First, we'll understand what are these AGVs and the classification. You know, whenever you want to study something, you want to define it and then classify it and then users and all that. We will go through that very quickly, maybe in the first 15-20 minutes. After that, I have a case study for you. So we have designed one AGV which is for serving food. Suppose if there is a restaurant with rows of tables. So from the kitchen to the tables, how we can do it in a non-contactless way. So that is something that we are working on. I have brought one model that we have designed and fabricated. Hope it works because it has come all the way from Hyderabad. It's a prototype. So don't be disappointed even if it doesn't work. I have a video. You can see that video, right? So like I said, whenever we talk about new things, we start with definition. I'll come down if you don't mind. I'll be more comfortable walking here, yeah, so that I can also see the. So these are autonomous wheeled vehicles, yeah, autonomous wheeled vehicles, which have got lot of electronics attached to them, so that they'll be safe and they'll move in a particular guided path, and it's more like a mechatronics kind of device. It's not just mechanical, not pure electronics. There's a lot of software into it. There's a lot of intelligent sensors are there, and of course the design of the mechanical structure itself is very interesting, right? So it's a very good project if people from computer science, electronics, electrical, mechanical, they can form a team and work on this. So some of the, it looks like this. This is a warehouse in which these AGVs are transporting cartons. This is another one where the AGV is pulling a lot of what do you call racks? Yeah. I'll show you a lot of videos also. So what are the advantages? So basically in factories or in any place where certain things are to be transported from say place A to place B, you will see that in many situations, like in steel plants, big steel billets have to be transported. In hospitals, the laundry has to be transported. In restaurants, food has to be transported. And in warehouses, all the packages, they have to be neatly sorted and they have to be transported to various points where they are tagged, bagged, and given to couriers. So the important thing about apart from being automatic, not needing human intervention, is it gives layout freedom. So by that I mean you are not fixed by anything on like a rail or something. So suppose tomorrow if from point A to point B, instead of point B it is going to be point C, it's very easy to change. So that is one of the biggest advantage apart from being automatic. And it's very consistent, ergonomic, safety and all those things are there. And it is scalable. Suppose if tomorrow you want to transport more devices to more places in your factory, from assembly cell 1 to assembly cell 2, and something new has come up, so your layout is growing and you want to do more things, transport more things in between those workstations, it is easy to scale up because all you have to do is add more devices. So that is one thing. They are also scalable. Improved ergonomics. Ergonomics in the sense it's the comfort level of humans, the safety of the humans will be much more because they need not lift weights, they need not push weights, the wheels don't go over the toes of other people, so accidents will be less. And in COVID times, another big advantage is the AGVs minimize infection risk because people need not come in contact with each other. So these are some of the advantages. So these are some of the application areas. You can see it's the thing on the left side. It must be nearly around a ton or a ton and a half. So such a big thing can also be transported on shop floors. And here you can see an assembly line where the car assembly is going on. It's going from one stage to another stage, and in a predefined path. There are some more applications. See, paper industry was one of the earliest to adopt these AGVs because the paper rolls are very big and transporting them is a huge task. So AGVs are used in paper mills, and not only in paper mills, but where printing, wherever we need paper and wherever we deal with big rolls of paper, right? So you can think of many application areas. These are some of the things I. So you might have seen the photographs on the left side. These are much before COVID came. Hospitals used to sanitize the surroundings using UV rays. So these are UV tubes, and they used to take them around the hospital rooms and wherever operation theaters to sanitize and sterilize them. So all the more important that they should be automatic, because you might have read that ultraviolet rays or whatever rays they emit, it's not good if they come in contact with the human skin. So only they kill germs, but if accidentally humans come in contact, it's not good. So it's all the more sensible to automate that task. That means you just put them on an AGV and program its path. It will go from room to room, just make a round and sterilize everything. This is a classic e-commerce warehouse situation where in Amazon facility center, or there's a particular name I forgot, where they did the warehouses, So there will be so many orders to be fulfilled, and so many different sizes of packages will be there, and there are a bunch of packages and there are so many addresses. So somebody has to carefully read the tags and put them. This is going to Bhopal, this is going to Indore, this is going to Chennai. So after all these things are done, they have to be put in their respective allocated places so that they can be picked up by the people. So all those things are highly automated, and you'll be interested to know that there is one company in Delhi, or a Grey Botics, which has been acquired by Amazon, because whatever they are making, whatever they are doing research in AGVs, Amazon liked it so much, they acquired a stake in Grey Robotics, Grey Robotics. You have to Google and find out, right? So now the classification. It is difficult to classify something like this, but I made an attempt. So there are basically three types of AGVs. One type of AGV is like this, wherein it will be flat bottom, and it can go underneath what do you call a rack or something, lift it up and take it from A to B, and it can also have a lifting mechanism built into it, as you can see in the lower in this lower left corner. So there will be some scissor mechanism to lift. So why we have to lift things and to move it, you will see when I show some videos. So for now, just see these things. So these are unit load. That means you can keep one carton or one tray or one crate or one bundle on it. So these are devices which we can handle only one unit load. So these are tug type or trolley types. You can hook them up to carriages like the grilled. What do you call it? Trolley, yeah, that's the word, trolley. And it can be moved from place A to place B. Everything will be automatic, right from rate, that this is the right trolley to pick up or not, and from there to hooking that, and then pulling it, and then taking it through a predefined path, and then leaving it there. So that is, and this is forklifts. Forklifts. Pallets, right? Pallets are wooden platforms. They have an empty space below wherein the forks can go in, and then they get lifted and then they move from place to place. Or they can have grabbing handles if you want to move paper rolls. So these are forklift types. So there are many more, but these are a few. So these are some links which will take you to YouTube videos. But what I have done is, yeah, no, let us not go there. So what you do is you just close the presentation or minimize it and go to the same folder. Downloads. Yeah. So second one from it. Yeah. Open that. Yeah. So yeah. Don't open that. Open the fourth one. Yeah. Cut down the sound. Sound not required. It'll only minute or minute and a half, please bear it. You can see something is lifting it and then carrying it. Yeah, and now it's dropping there. So the lifting mechanism is built into that. It can be a hydraulic mechanism. Let us see if we have anything interesting in this. Or we'll go back to the presentation. One more thing is there. Yeah, go to the tugger thing. Yeah. Observe the maneuver it does. It's very interesting. So now we can appreciate that, if you want to change the layout, all you have to do is change those black lines on the ground. And if you want to handle more, load, you have to deploy more devices. So layout flexibility is, will be there. Yeah, we'll go back to presentation. Yeah. So what are the basic building blocks? Suppose tomorrow as a final year project or a mini project, if you want to build an AGV, you should know what are the basic building blocks. If you want to build an AGV, what do you need and how do you identify those modules? So this slide helps you in identifying them. So basically it will have a chassis and of course it will have driven wheels and idle wheels. So we'll see that in a minute. And also it will have a lot of safeties, like it should not crash into somebody who is coming in between. And of course it should have a battery, and it should have the most important thing is you should have a control and navigation system. So it is an intelligent device. AGV is not blindly it's not like a radio operated car where you press something, it goes from A to B, because it's all pre-programmed. If you have a big facility, you can identify in software right? Like, this is my starting point, this is my ending point. You have to go all this to this route and all. So there's a lot of software involved, and that is control and navigation system. It's a bit of hardware and software. And the superstructure is dependent on what you want to do with it. Suppose if you want, if it can be, it depends on your application. Like, if you want to have, if you want to lift pallets, you can have a forklift like thing. Or if you want to drag some trolleys, you can have a hook on it. Or so superstructure is dependent on your end use. So these are some of the examples of chassis. So you can see there, like it has got 6 wheels. We'll see in a minute why 6 wheels are needed when we discuss the drive mechanism. Here you can see it's a 3-wheeled one, but if you observe the front wheel in the lower left one, the front wheel, it is both, it rotates as well as swivels. Like, it goes like this as well as rotates. Yeah. And the middle one, it is a lifter. It can lift up, pick up the load, go there, and then drop it. And here they have put a robotic arm on top of the chassis. So most of the time, most of the small and medium-sized AGVs, they have BLDC motors, and these BLDC motors will be having planetary gears in between, because the motor torque will not be sufficient of it. So there is a planetary gearhead attached to it, and of course the tire with polyurethane rim will be there, so that it will get enough grip on the ground. So that's very important. Because they rely on the friction on the ground, there are some requisites that the ground should neither be too smooth nor too rough. It should be like there should not be a steep slope. So all these requirements should be met before you deploy these AGVs. So here it's a little bit more complicated. This drive unit has got both a motor for rotating as well as another motor for swiveling it, right? So right, we have seen that it will have a chassis, it will have some idle wheels, and it will have some drive units, right? So the most important thing that these things should together do is steer the robo. That means, how do I steer the robo? Like, move, make it turn. So there are different strategies for that. The leftmost one is differential speed steering. So it has got 4 wheels. It can have 6 wheels also, front 2, back 2, and middle 2. So the front wheels, the front and back wheels are idle wheels. So they can rotate freely, and as well as they can swivel, like swivel casters, right? Many of the wheelchairs will have swivel casters. And these are driven wheels. And how do you steer it? Whenever the speed difference is there between the left and right motors, it will go in one direction, right? Suppose if the left motor is rotating in the forward direction, and if the right motor is rotating in the backward direction, it will turn like this, so like that. So this particular thing has got a swivel steering. So another way of steering it is have one motor which can both do rotation as well as it swivels, and it also provides direction. And this is another strategy. The last one is where you can steer both the wheels. So the advantage of this is it can move sideways also, like a crab. So instead of turning like this, instead it can go from here to here. That's a big advantage in warehouses where space is a constraint. Anything which needs to turn should have a turning radius. So if you have a mechanism like that, instantly it change direction, like like a rook in a chess piece, right? So this is a point where we have to see some videos. Can we go back? Go to the second video, please. You can cut down the sound. So these are idle wheels, they back to let's drive and steer. I think there's an animation also, yeah. This is interesting, differential drive. In our robot, we have implemented this. So if you observe carefully, there's a speed difference, like, one is moving in anti-clockwise, the other is moving in clockwise. Yeah, that's enough. And one more we will see. Yeah, the leftmost. Yeah, this has got 4 wheels, and all the 4 wheels are powered. That means there is no idle wheel, and all of them are survivable. So the degrees of freedom it can give is enormous. It can go any which way you like. And by the way, that motor is a hub motor, like the one you use in electric bikes. It's a hub motor. Yeah. We can see one more, I think. Yeah, close it. Yeah, I think that's it. Yeah. Go back to presentation. So, the most important dilemma we face, the most important question that we face whenever we design something with motors, especially people who are doing it for the first time, is this motor big enough? Can this motor give me the speed and the torque that I need for my application? So for that there are so many online calculators. So one such calculator is given there. We will just briefly visit the site. But very, if you input your load requirements, speed requirements, friction, the ground conditions, it can give you what type of motor you should use. So, although PLDC motors are extensively used, for very small applications, non-critical applications, you can use brush DC motors also. So, again, which type of batteries to use is a big decision point, right? So you can use the sealed lead acid batteries, SLAs, or the trend is now to use more lithium-ion batteries. Lithium-ion batteries can be charged very quickly, and they also pack a lot of power in a very small volume and weight. So if you see the power to weight ratio, lithium-ion is a good candidate but very expensive. But there are advantages. It can be charged very quickly. And if you go for lead acid batteries, they are very cheap, but takes long time to charge. One small video is there where they implemented battery swapping. Battery swap somewhere there. Yeah. See, the AGV has got enough intelligence built into it. Whenever it sees senses low battery condition, it comes to the station, and where a person can simply swap the battery. He has got a nice jig where you can simply swap it. Something like this should be done for electric cars also. So AGV goes off from there to do its assigned task, and this battery will get charged. I think, yeah, he's charging it. So this will be ready. Yeah, we'll go back to presentation. Yeah. So you understand it should have a chassis, it should have wheels, some of them are idle wheels, some of them are drive wheels, and it should have batteries and all that. But the most important part is navigation. What are the strategies for navigation? How do you put enough intelligence into it so that the navigation is controllable and programmable? So there are different strategies for that also. The most common and the most easy to implement one is the visual one. Like, either it can be a simple line drawn on the ground, or it can be a magnetic strip where you can sense it to the magnetic sensor. There is a company called Robotech. Even in India, they are selling, where they give you a magnetic tape with adhesive backing, so you can just put it on the ground, and then there will be a sensor which is attached to the vehicle. It senses that, and it follows the center of it. The vehicle follows the center of that line. And sometimes, high frequency electric lines are also embedded, but that is very rare now. Yeah. So 5-6 years ago, drawing line on the ground and making the robo follow used to be very low tech. People used to think, "Arey, what is this?" Sometimes it's very error prone. It depends on the ambient light conditions. So controlling the robot used to be very difficult if it is done visually with the line drawn on the ground. But now, very high tech cameras have come. We are not using those infrared sensors. I think some of you might have done or seen line following robot, right? It has some sensors in the front, infrared sensors, where if they see black line on a white background or a light background, the feedback will not be there, or the feedback will be very less. And if it doesn't see, the feedback will be there. So that is taken as an input to give command to your steering, so that slightly adjust it and bring it to the optimum position, right? But coming back to that, nowadays the line following robots are come back into action in the industries because people are not using infrared sensors, but people are using cameras which have got lot of vision software built into them. There's a lot of artificial intelligence which can not only sense the line, but they can also sense if you place any QR code by the side of it to tell it that it has to stop here or it has to take a turn here. So all that intelligence is built into it because you are using an intelligent camera to track the line, not simply IR sensors, right? So this is line following navigation. Still very popular, very robust way of doing it. And the other type of navigation is laser guided navigation. So what it will have is, the vehicle will have a pole or some kind of a rod like thing. It will have a it will have a lidar at the top, and it will be emanating waves, and then it will reflect us. So by triangulation, if it by choosing any three reflected points, it exactly knows where it is, and accordingly it follows the path. So this is very expensive, but it's very accurate. So another important thing is natural navigation, where there will be a lidar which can also be used for obstacle detection, but it also kind of maps your road. Like what it does is, first of all, if I want to implement an AGV in this room, like if I want to serve all of you with refreshments or tea from all the rows, let us imagine that there is enough space between these each row. I have to place a path like this, like this, like this, crisscrossing all of them, right? So first, what we will do is, in the initial deployment stage, the robo will be made to do all these rounds, and while it is doing it, it kind of maps the environment. So it creates a map, and it knows where the seats are, where the tables are. So all the physical objects in the room, they get mapped, and next time when you ask it to go from A to B, it calculates the most optimum path and it follows it. In addition to that, it also does the obstacle avoidance. So having a lidar has got both the advantages: obstacle avoidance as well as mapping. So this is natural navigation using lidar, and I don't know if any of you heard of ROS, robot operating system. ROS. So ROS is like, how shall I say? It's a platform for it's an open source platform for robotics. If you have a 6 degree or 5 degree robotic arm, all those inverse kinematics, you need not do the trigonometry to know, if I rotate this by 5 degrees and rotate this joint by 6 degrees or rotate this joint by another 8 degrees, where will my end point be? So all that calculation will be done in the background for you. You just have to give it that I want the arm to extend from say A to B. So all the inverse kinematics it internally does, and it throws out the required angular joint values to your motors. right? So something like that, ROS can also work not only with articulated robots, like robots with joints, but ROS has also got several libraries which can be used for AGV also, right? So ROS can work with LiDARs. There is a very good tight coupling between AGV and ROS platform. You can explore that. That will be a very good final year project. So there's a comparison here. Of course, we should strictly not go by it. But they say that some are cheap, some are easy to implement and all that. But we have to take this with a pinch of salt. So what is good for him may not be good for us. But by and large, this is general agreement. Yeah. So these are some of the things that we use in advanced navigation, how they look like. So this is the first one is LiDAR. It comes in different shapes and sizes, but this is one of them. And suppose if you want your AGV to work outdoors, where there are no markers at all. So how do you do it? So there you use GPS. So if you use a GPS sensor in your AGV, it directly talks to the satellites above, and exactly by triangulation it knows where it is. So suppose if you have a food delivery robot, where in your local area, let us imagine that there is a library guy, right, who comes to a colony. He need not go to each house to give libraries. Already booking has been done. All he has to do is give those books to those respective houses. So what he will do is he will just come to that colony and put all the books in, the required books that colony people ordered in this small AGV, and directly it goes from house A to house B, because it knows its position with GPS, right? So IMU is important because you should know whether your robo is tilting, turning, this positional, the physical position in the space. Yeah. So what is the time now? Yeah, very good. We are doing good. Yeah. So now I told you that we have built a small AGV. So this is how it looks like. We can see it physically. After we finish this, we can bring it on this, show it to you. So basically, it has got an aluminum structure like this. So these are 30 by 60 aluminum T-slot profiles. I think those of you who have not heard or worked with aluminum T-slot profiles, they should immediately start, especially mechanical engineers who are like working in mechatronic projects or who want to build something. They give you an easiest way of building structures. Yeah. So please explore T-slot aluminum profiles, how to work with them. You can build anything, practically anything with them. So we have made our chassis with that, and it has got 4 swivel casters fixed like that. And next, our drive unit is like this. So it has got a BLDC motor. I think it's a 50 watt BLDC motor, which gives a torque of around 20 kg centimeters. And it is coupled to this end. How do you make the pointer come? Pointer, maybe this one. Yeah. So this is bolted to these 4 bolts, and the shaft is this is the coupler. So this couples the shaft and the wheel, and this goes to the chassis, and this bracket is just pivoted. It kind of moves around that. Why it is needed, we will see in a moment. So there are 2 such things, one on the left and one on the right. Yeah. Now you may be asking one important question, or it should occur if you really start building. It should occur to you, why we can't simply put these motors in the front or back and be done with it? Why we should take the trouble of putting 2 motors in the center and have 4 wheels, on the surroundings? So instead of the front, we can put these 2 there, because this mechanism is good in 2 ways. One is, suppose imagine that you put these 2 in the front. The immediate impact will be they'll be taking the whole load of your payload, whole payload. Yeah. And secondly, steering will become very difficult. because if it is in the center, the turning moment required will be less. Whereas if it is in the front, the turning moment required will be more. So there will be a tendency for the wheels to slip on the ground. And if you observe carefully here, yeah, if you observe carefully, this whole thing can move up and down a little bit. This whole thing can move up and down. That means these two wheels are only providing motion. The actual load is coming on the casters. So that is the beauty of this design. So, and another advantage is you need not use any heavy bearings to support your wheels, because they are not taking the load, they are only providing the traction from the ground. So the actual load is coming on these four wheels, and always, because there is a degree of freedom, it can move up and down a little bit. Even though ground is slightly uneven, it kind of always maintains contact with the ground. Another thing is you should have a very broad wheel, preferably with what do you call resilient material, preferably natural rubber or polyurethane, so that it will have enough grip. So that's another important thing. So we have put one more layer on top of that. On this, all the electronics will come, and then there will be a top cover. Right? It looks like this. Then we have fabricated one more, structure like this. It's called the superstructure in this particular case, so that it can carry two trays. Suppose if somebody is using it in a restaurant, serve food, so they can keep one tray here, another tray here, and the lower portion can be used for carrying the used cutlery. Yeah. So this is what we are saying that it can do. It can do. Suppose this is simple implementation. This is the kitchen, or where the food is put in plates and orders are getting executed. So from here it can be loaded and it can be taken to each table. Sorry. Yeah, steering will go back. Yeah. See here, if I want to steer it, how will I command it is, suppose let us imagine that you are not turning this motor at all. If you are turning only this motor, either clockwise or anti-clockwise, and not turning this motor, yeah, it will go like this. It will go like this. And if you are turning both the motors in the same direction, it moves forward, and vice versa. If you are turning in the reverse, but if you are turning in the opposite directions, it will pivot around its center. Suppose if this is the center of the, the geometric center of the AGB. If you rotate both of them in the same speed but in opposite direction, it will spin, right? So steering is done purely by speed control of the two DC motors, BLDC motors in this case. So steering is done by like that, right? It's called differential steering. Yeah, differential steering. Yeah. So this is the implementation of the electronics. So we have, I told you that there is a camera sensor. So this is the camera sensor. It's Pixie. There are newer camera sensors which are cheaper and much easier to use. So and these are ultrasonic sensors for obstacle detection. Because this hasn't got a LiDAR, we have used ultrasonic sensor. You can even use infrared sensors also for obstacle detection, but we have used ultrasonic. These are very cheap, and these are the two BLDC motors. And BLDC motors just cannot be driven by from Arduino anything. So you need a driver for that. So these are the two drivers for providing the correct voltage to the BLDC motors. And this is the battery, and this is the DC-DC converter, because Arduino works at 5 volts. This is a Mega, by the way. Arduino works at 5 volts, and this battery is 12 volts, so we need a DC-DC converter. And this is a Raspberry Pi. Raspberry Pi we are using as an onboard small computer, so that we can make small changes in the program on the fly. In the sense, every time I need not, if I want to change any program in my Mega, I need not take the cable, take my laptop and do the software changes. All I'll do is I'll connect to this Raspberry Pi through Wi-Fi. You know that, right? Pi can get through. So actually the mega program will reside in this, so I can access it, access the Arduino file, make the changes and do it wirelessly. So that is one advantage, right? So of course we have made some changes in this, but this is not the latest, but that's fine for your understanding. This is the implementation, right? So any quick questions? We'll bring the device and give you a quick demo. I'm afraid it may not work very satisfactorily here because the background is a mix of, it's not uniform, right? But still we will try. So I think one of my friends has volunteered to help me. Yeah. Yeah. Yeah, it is here. Yeah, we have remote. It's very difficult to transport it with all those things. So we can run it. I have my phone. That's here. No. Still more to come. This anybody can do. So yeah. So what we'll do is now we'll paste a black tape and see whether it follows the tape or not. I cannot guarantee that, like I told you, because the background is not uniform. So anyway, let us go ahead and paste the tape. Yeah. So follow this. Wait. Okay, we have given it this Bluetooth control functionality because initially you have to put it on the track. Like, you cannot really lift it and put it on the line, right? So now it is on the line. Now this is the real test. Whether it follows this line or not. Because I told you that if the background is not clear, it will not identify the line properly because it has got its own limitations. Now it is in manual mode. I'll put it in auto. Let us see. Yes. You can take the curves also. Yeah, that's right. So one more thing. Now it is going from A to B. That's not a big thing, right? It has to stop programmatically. So for that we have RFID cards, which I have there. I'll bring them. Where is it? Yes. So what we are asking customers is, so the customers have to provide a line like this wherever they want this to be implemented. And suppose there is a table here and there is another table there. Yeah, let us see. Let us say this is one table and this is another table. Right? Yeah. Now let us put it in auto. And I'll select the this table and also this table. It stops for 1 or 2 seconds and it goes, the table call is answered and it goes to another table. Yeah, detected. This goes off and it proceeds. And at the end of the line it stops because it cannot see anything. Right? Thank you. So this is a small thing that I wanted to share with you. See, this is something that you can easily implement. It is a very small and doable project, and it is also kind of multidisciplinary. Like instead of computers people doing one thing and electronics people doing one thing, a small team can come together, divide the task and build something like this as a final year project. So guys, this is what I wanted to share. And what's the time now? Yeah. So if you have any questions, I'll be glad to answer them. Very keen to go for lunch. No more questions, right?
Can we hack AGV?
Sorry?
Can we hack AGV?
Hacking AGV, if it is on the network, yes. But this is a very simple implementation. This is, we are not exposing, there is no Wi-Fi connection, so you cannot hack into it. But yes, if there is a fleet of AGVs, and if somebody wants to interfere with their programmed what do you call movement, they can do it. Yeah, please sit down. Yeah, in short, my answer is, if it is network and if it's a big fleet control, you can do it. But this has no Wi-Fi control, you can hack it. So, okay, I'll be very happy if some of you can take it up as a project, because it's interesting and it's very multidisciplinary, and it brings it will give mechanical students a flavor of the electronics and software students a flavor of mechanics. There is no end to it. You can improvise it and build different superstructure on it to improve its functionality. Any other questions? If not, we will stop.
Before that, anybody here from third year, mechanical or ECE? Please raise your hands. Electronics, electrical. So even electrical students are also there. So sir mentioned that you can do a project. So this can be done as an interdisciplinary project. If third years are not there here, you can invite your friends who are there in third year, and you can combine one team and you can submit a project. So sir will help us. This is one idea sir gave. So it's your opportunity, it's your turn now, how to utilize that. Or completely hardware project. Is it clear? So I think third years, right now you do have mini project. I do remember, isn't it? Scheme 17. Mini project is there.
Yeah.
2 mini projects and 1 major project.
So sorry, you can start off as a mini project and then improvise it. You can, this is a very basic device. It has got very, less intelligence. But as a group, you can do web search and make it more intelligent. And one small thing I cannot help making telling about this project in general is, I give such presentations in many colleges and always say this, even though the students don't like it. Make your projects look classy. It's not that don't save money in making projects. You if it has to be a machine, you have to machine it. How should I say? If somebody sees your project, it should say it is just a step away from commercializing. Don't make a hodgepodge thing like put some glue here. Don't make it look like the standard college project. Make it look like a commercial product or very close to it. So please spend some time so that if tomorrow if some venture capitalist or somebody comes, they should feel, oh, it's very close to commercialization. Come on, I'll fund it, and then you should take that idea and
In this, I'd
take
like
you
to
over.
add that Mahindra company owner.
Yeah.
Wherever such type of projects are
Yes,
there,
Anand Mahindra, he spots those things, and he always says that come to me, I'll fund your projects. Yeah. So it does not only this, whatever you do, see, we students spend a lot of money. It's none of my business, but you spend money on dresses, you spend money on cell phones, yeah. You spend money on parties. All that is there. That is one part of it. But spend more money on learning things. So whenever you don't think you should do it at the lowest cost, try to do your project in the best possible manner. If something has to be see that machine, if something has to be painted, it should be painted. If something has to be, instead of just connecting wires, if a PCB has to be done, do it. So plan it and execute as a very good. Of course, as a pilot project, you can do a quick and dirty prototype, but when you show it to in forums like this or in your final year exam, so when the GPREC students have done something really great, their projects are every time we see the quality should be very good. It should speak. The quality should speak. So that's all. Enough of GAN. Thank you.
anything from still students? It's open for about 5 minutes. ఏమన్నా అడగాలన్నా క్వశ్చన్స్ అడగచ్చు లేదా ఎనీ సజెషన్
ఏమని అడగాలన్నా అడగండి. I speak very good Telugu. My mother tongue is Telugu.
Anything from girl side? No? Feeling hungry?
Yes.
Okay, one more thing, sir, when Chakradhar is explaining about his project, sir also got some idea. So if you want, we'll support.
So
him.
yes, that's something very quickly. That is how ideas. When you meet people, see things. Quickly. You can connect them. Suppose if you make tomorrow something like this, and if you want to give a presentation to customers, then it's a good thing to have in warehouses. It's a good thing to have in hospitals. You cannot really take it to hospital, take your customers to a hospital and show it there, right? So that's where virtual reality comes into picture. So you can create a hospital-like atmosphere and make this go from place to place or anywhere, a manufacturing scenario or an SLP. So that is something that not only this, anything virtual reality as a marketing tool or as how you can show your product in real use, like in although it's virtual, but it's very close to reality. That is something you can think of.
If any student is interested, not only student or a team of students is interested to design this type of thing in virtual model, we'll feel it happy and then we'll submit to sir also. They feel very happy. Is it clear? చేయగలుగుతారంటే చెప్పండి. We'll definitely support in that aspect. So in that demonstrate చేశారు కదా, same thing should get designed, developed in VR.
So you guys saw in my session, right? How we are leveraging AR and VR for other applications like engineering applications. So this is also one type of application, guys. In pandemic, where this complete robotics was automated by XR technology. We will be wearing some headsets and we will be somewhere into the remote place, and we will be operating a complete robot that might be automated in like in our factories or wherever it could be. We will be controlling that robot from XR. So even I have seen many use cases that what Sir was explaining in the session. So if you really interested in making one prototype on that, I would be sure I would be glad to help you guys. Okay, you can reach out to me. Okay, thank you guys.
అంటే వెరీ సింపుల్ అండి. ఇది ఫిజికల్గా సార్ చెప్పారు కదా, ప్రతి చోటకి ఫిజికల్గా తీసుకెళ్ళి డెమాన్స్ట్రేట్ చేయడానికి కొన్నిసార్లు ఇట్ విల్ నాట్ సపోర్ట్ అస్ ఆర్ ఎన్విరాన్మెంట్ మే నాట్ బి పొజిషన్ టు show demonstrate or demonstrate experimentally. But with the help of a VR headset, alert Chakradhar design station, with the help of VR headset, you can completely explain that to the management that may be of any institution or any organization. This is how our product will be. That is one type of market. So even for marketing also, this virtual reality can be used in a better way. So if you people are anybody interested to do one project on this, one is experimental project, directly a prototype model what started, and another one using VR also. You can demonstrate it. So definitely college will be there to support whatever that you want. But only thing is you need to bring a real project. As sir said that must be a classy project. Classy in the sense very much what we can say. Now you can see how much it is classy. It's not like just a vague type of project, isn't it? So in that way, you can do it. Definitely, college will support in that aspect. And coming to the VR aspect also, we'll support in whatever way that you want. The design cheyalana kuda, we have the teams. Chakradhar is there to help out. Clear? But only thing is, me nunchi determination, interest undi vastene andi. Otherwise, there is no meaning calling all these professionals, very much expertise people. వీళ్ళందరినీ పిలిపించేది కూడా మీరు రేపు పొద్దున్న ప్రాజెక్ట్ చేయడం కోసం. అల్టిమేట్గా ఎనీ స్టూడెంట్ బెనిఫిట్ పొందేది ఎక్కడండి? క్యాంపస్ ప్లేస్మెంట్కి వచ్చేటప్పుడు నేను ఆ ప్రాజెక్ట్ దగ్గర మీరు డెమాన్స్ట్రేట్ చేయగలగాలి. ఇఫ్ యూర్ ఏబుల్ టు డెమాన్స్ట్రేట్ ఇట్ విత్ వెరీ మచ్ కాన్ఫిడెన్స్, దాట్ విల్ హెల్ప్ యూ టు గెట్ దట్ జాబ్ ఇన్ దట్ కంపెనీ. సో అలా మీరు ఇంట్రెస్ట్ చేయగలిగితే డెఫినెట్లీ వీఆర్ దేర్ టు సపోర్ట్ టు వాట్ ఎవర్ ఎక్స్టెంట్ దట్ వీ నీడ్. థ్యాంక్ యూ. ఎనీబడి ఎల్స్? I request XCOM go for next item.
I P Pushpalata, Child of Industrial Application Society, IEEE GPREC SB. Feel immense pleasure to propose vote of thanks to Mr. Sadand sir. Thank you, sir, for sharing your extensive knowledge on automated guided vehicles, sir. It was undoubtedly an educational lesson. It gave us a lot of information on automated guided vehicles. We were undoubtedly touched and guided by your extensive knowledge of the topic, and we believe that this will be a great assistance to all of our fellow students in developing new ideas in emerging technologies. Your
So we requested Sadand sir to be as one of the guests during the valedictory function. So even two more resource persons are also there. All those three will be there during the valedictory function. I request all the participants be present in the valedictory function to get good message from these three persons. Okay. Next question.
Are you exhausted? Yes, I can hear no and yes both. Yeah. We'll have lunch. Before that, let us continue with the dance performance by Chaitra from first is CST. And now welcome Chaitra. dancing now. Okay, everyone, listen carefully. ఇప్పుడు మీకు లంచ్ బ్రేక్ వెళ్ళండి 2 కి కరెక్ట్ గా వచ్చేయాలి. 1:45 కి కరెక్ట్ గా వచ్చేయాలి. 1:45 రిపీట్ 1:45. 1:45 కి పర్ఫార్మెన్స్ ఉంది. సరే ఇప్పుడు వెళ్ళండి బాయ్స్ ఫ్రమ్ దట్ సైడ్ అండ్ గర్ల్స్ ఫ్రమ్ దిస్ సైడ్ ద సేమ్ ఆర్డర్. By 1:45 you have to be here. By 1:45, otherwise you will be missing the performance.
ఎవరు సాల్వ్ చేశారు ఇప్పుడు సాల్వ్ చేశారు
మేమేం చేసాం అది ఏం చేయలేదు.
ఏం చేయాలి అన్ని చేస్తావు.
థ్యాంక్ యూ. రుమాన్ స్టాప్ చేయట్లేదు, నాకు అర్థం కావట్లేదు. స్టాప్ ఆఫ్ ఏం క్లోజ్ చేయాలి ఎట్లా? డైరెక్ట్ ఇంటూ వచ్చుతున్నావా?